This is our assignment question number 11. So here first step is to just you have to equalize, okay, whatever question is given. From there you have to assign the s1 value, s2 value. Those are the value we have to slack value usually we have to assign, since this is a maximization problem. So we have assigned the slack value for first resource. This is the first constraint. For that we'll assign the value of s1, and this is my second constraint. I will assign the value of s2 to it, slack value. This is my third constraint, so s3 value I'll assign. Okay, so we already know that whatever in constant we are assigning the slack value, its coefficient will be 1, and the same we will write it here along with the objective function. There the coefficient will be 0. So nothing we do here, we are just adding. In first step is to just add the slack value, that is s1, s2, s3 here also, and in objective function only, and we have to just keep in mind the coefficient. So in constant the coefficient will be 1, and in objective functions the coefficient will be 0. So this is what is our first step. Now moving on, we have our second step, where we have to make one initial simplex table. So here we'll get some kind of solution. We are basically trying to check what will be the value of zj minus cj. Okay, it has to be positive no matter what, it should be more than 0. Here how do we find that? Actually the initial is very easy. So nothing you have to do, you have to write first cb, that is nothing but coefficient of basic value, and then we have to write what are the basis. Basis is nothing but here we have now these all these things, x1, x2, s1, s2 and so on, right? So same thing we'll write, and the other two rows are like solution and ratio. How do we find that? That is solution, this all the things divided by key column, that we'll find later. We'll come to know what will be our key value, key column, and we'll divide that and we'll get the ratio. Okay, these are this ratio, and this ratio usually helps us in finding about the key row in later phase, in case this is not the answer. So not getting to that, first let's focus how do we make this table. Okay, what will be our basis? So basis here, in that we will usually write the slack value whatever we are assigning. Suppose here in this case we have assigned 3 slack values, that is s1, s2, s3. So simply we'll write that. Okay, here basis is nothing but all the things like x1, x2, or s1, s2, s3, everything you write it here, and whatever coefficient is assigned to it, that is before that whatever comes, like for x1 we have 30 as a coefficient, x2 40, s1 0 0 0, and for s1 again we have here s1 again we have coefficient is 0, to write it the same thing here, 0 0 0. By default in first one, whenever you're making the initial simplex table, there the zj value will be always 0. So you don't need to worry. How did we get that? That is simply by multiplying this value into this value. Okay, again this value into this value. Okay, so whenever you will add these two by multiplying into 0, you will again get the 0. So by default in first case always zj value will be 0. So simply I have written. Next is we have to check zj minus cj. It should be as I already mentioned, it should be positive. Okay, if not positive means this is not the optimal solution. So here how do we find that? So zj value is 0. Okay, and cj, this is what is cj. So 0 minus 30, it will give minus 30, 0 minus 40 minus 40, 0 and so on, right? So we find that, and after that since we got the 0, okay, I have written, since zj minus cj, it is not it is negative. Okay, so this is not the optimal solution. So this is how this table ends. Okay, so now we have to make another table. Okay, for that we need some data. What kind of data we need is first you take highlight the key column and key row and key element. We have to find. How do we do that? So here you see, here in zj minus cj, what is the maximum number? Like here the biggest one is which? Minus 40 40. Okay, so this is the most negative in the sense that is it's the minimum value. Okay, minus 40 is the minimum. Okay, so here whatever comes above that, you just color it. Okay, this will become our nothing but it is our key column. Okay, next is we have to find the ratio. Okay, till like we have entered in I forgot to say what values he will enter here. That is nothing but since this is s1 deals with a constraint number 1, we will enter the same value for x1, x1 value will be 60, for x2 here 120, for s it's one coefficient, but we don't, in this constant we don't have s2 or s3 something, right? So we'll simply write 0 0, and here solution is this value, RHS value, that is 12,000. okay, we'll write this again. You see s2, okay, s2 stands for which constant? Constant number 2, right? So here we are getting the coefficient as 8, here again 5, and we have only s2 here, so for s2 the value will go as 1, and for other we don't have s1, we don't have s3, so we'll assign it as 0, and again the RHS value 600. okay, same thing goes with the constant number 3 also. So why do we need this, all the things? Solution part is to find the ratio. How do we find the ratio? That is solution divided by key column. Now only we have found key column, okay, that is the most negative value will be considered as the key column. okay, so this is our key column, and we already have the solution. So divide 12,000 divided by 120, we'll get 100. 600 divided by 5, 120. 500 divided by 4, 125. So we got everything. okay, and this data, and then here after finding the ratio, whichever is least, that what's that row you have to color, okay, that you have to select, that's all. Why do we do this? In order to find what will be our key row, what will be our key column, and what will be our key element. okay, so key element is nothing but the point of intersection. So here you can see, so key element is nothing but the point of intersection. So here you can see, like this is some T shape where both the points are meeting at 120. So this is our key element. okay, and key row is nothing but this one. okay, this is a row, and here the value of ratio was the minimum, so this is our key row. So what is the basis of it? It is represented by s1. so s1 is our key row, and now key column that we found, that is most negative, will be our key column. So x2 becomes our key column. So what we do with this, actually these are the basis for formulating the next table that we are going to make in order to find the optimal solution, because this table has not given us the optimal solution, as the zj minus cj value was negative. okay, it has to be positive in order to be an optimal solution. So now key column is always the entering variable. okay, key row is the leaving variable, and this is interchanging variable. So what do we mean by leaving and entering variable? Here is that here in this, here we have s1 as a key row, right? So this will be leaving. That means in next table we are not writing s1. In place of s1 we are going to write x2. okay, we are just simply going to write x2, and we will enter the value, and later on for determining the value of x2 when it enters in this table, okay, as a basis here, okay, we will be using the interchanging element. We have a formula for that. Let's see what's that. Yeah, so we come here. Just now I mentioned that our leaving variable, leaving basis is s1. In the place of s1 we will be getting x2. So simply we write x2, and the same thing, s2 will remain same and s3 will remain the same. Again, what we do with all these things, we write the coefficient, whatever is means nearby that, right? Before that, so coefficient, already if you look at cj, you will, these are the coefficients. okay, the same thing you have to replace here. For s2 it's 0, and s3 it's 0. For x2 it's 40. Write the same thing. okay, and now how do we determine the value of x2? Actually in that it was something called column, right? You would have seen here. See, this is x2 is our column here. Now we are making this column into row, so we have to find its value. How do we do that? okay, for that we have got a formula. okay, so already I have mentioned x2 is a entering variable, right? We just found. So its formula is old value divided by key element. okay, we found key element right here, key element, that is point of intersection, right? So this is 120. okay, now we put that in formula. Old value is nothing but the value of s1, which we have now replaced with x2, right? So we will write the value of here S1 first, like x1 x2 everything we'll write x1. Here we have the heading now, everything we'll write it, okay, till solution. And for that we will determine the value what will come here, okay. So old value refers to the S1, okay. So here just check what is S1 value. It's 60 120 100 12,000, right? So here we write the same thing, and we found the key element is the intersection point is 120. We write the same here, we try to divide that, okay. We get these value, we are just going to write it, okay. And since this is our new table, okay, and the previous one was not the optimal solution, we have to again determine what will be the new value, because all the values we are changing it here. I mean the column has been converted into row, and here S2 and S3 actually if we enter the previous data, it is not going to bring any changes, and we will not be able to determine the optimal solution. So we have to again determine according to the changing table. So how do we determine that? For determining S2 row value, we have a formula. That formula is nothing but you have here that is you have row S2 value that is other than the entering variable. Why do we write other than entering variable? This is because we have already determined whatever will be here that key column, okay, key column, that is known as entering variable. X2 is only known as the entering variable, and X2 because this is what we are entering in place of S1. Other two, these two are already the existing ones, so we name it as other than the entering variable. And for that we have a formula: new value into multipliers plus old value. Multiplier is nothing but we have earlier in first table we have colored this, right? We have found the key column, right? So key column, whatever is corresponding to that, like suppose we are here now we are finding the value of S2, okay. For S2 what will be the multiplier in the same key column? You have to see here 5, okay. If we have to find the key column multiplier for S3, so again we will look at this key column, okay. The value is 4. Here it is positive, but multipliers usually become negative, okay. When we put it in formula, we have to use its negative for finding the value. So what we do here, just now we saw for S2 the value is 5, right? So we are just going to write it as -5. This is multiplier. New value is nothing but whatever X2 value you have found. Here we got 0.1 0.5 1 and so on. So this is our new value. Whatever you find as an entering value, that is your new value. Multiplier I told corresponding to the column like that we have highlighted, whatever is there corresponding to S2, you have to get that, and you have to just change the sign as a negative. And new say old value is nothing but the value of the S2 entire. So this already the first table which we have drawn here, so these are our old, that is basic, okay, historical values. We have to add write the as it is. So here you see 85010 the same thing is here I have mentioned, that is 85010 okay. Just try to simplify it. The same thing S3 is also, it is other than the entering variable, because we are not replacing S3, we are writing as it is, but we have to find the new value of it as we are entering in a new value. So again I told already new value is nothing but the value of the first one, entering variable, that is we found here now. Same thing again we write in for S3 also, we'll write the same thing like we did for S2 now. Same thing, this is our new value, it will remain constant. Again I told how we got multiplier -5, it was the corresponding value. For S3 we have the corresponding value as 4, so we will take it as negative, okay, since the formula says that we have to take the negative form. So we are taking the negative form, multiplying. Don't be confused, it's just I'm trying like multiply sign it is, okay. And here we have to add the old value. Old value refers to the historical value in the table 1. So for S3 the corresponding values are this, that is 34001 and 500. So we have written the same thing, okay, we have simplified, okay. And all this value whatever we get here, and here for x1 we have to put it in the table, okay. And again we have to do the same thing, we have to find ZJ, okay. ZJ, how do we find? That is nothing but here like we have x1 value, we'll multiply this with this, this with this with this, and we'll add all these things. Okay, so here you see, here it is for S2 and S3 it's 0. What is the use of multiplying? If you multiply with anything with the 0, you will get ultimately 0. Okay, so ignore it, just focus if anything is positive here. Okay, so here we are having x2 as a 40. So rather than multiplying everything and adding, we are simply just going to multiply this and get the answer. Okay, so we get is 40 into 0.5, we get 20, and 40 into 1 40, and so on, like we do multiply. Okay, after that we have to basically, in order to find the optimal solution, the thing is zj minus cj. Okay, it has to be positive. So here zj is 20 minus cj 30, so it becomes minus. Again, this is also not an optimal solution since the value has come as a negative. So we do the same thing again with this. Now we try to find out the key. Same thing we have to repeat for every constructing every new table. We need these three data, that is key column, key row, and key element. Okay, so for again for this we are going to find, so what was the basis for finding the key column? Key column is nothing but most negative. So most negative is minus 10. So we just highlight all these three. Okay, and then we have to find the ratio in order to find the key rows, right? So here we have to, what we have to do for ratio, we have to do ratio means solution, okay, divided by key column, है ना? Yeah, so key column is already found, this one. Okay, and we have our ratio given. So 100 divided by 0.5, we get 200, and 100 divided by 5.5, 18.818, and then 100 divided by 100, we get it. Okay, so we are going to write like that, and with the help of this again we are going to specify what will be our key element. So here the point of intersection is known as the key element. So here point of intersection is 5.5. so this is our key element, that is intersecting value. Okay, and key column is represented by variable x1, and key row is represented by the variable s2. So we again write it here already I have told that like we found the value of all these s1 and s2, and we found that since this z value was greater than 0, so this was not the optimal solution. So we are again we have tried to figure out what will be our key row, key column, and key element, that is s2, x1, and 5.5 that we have discussed here. That is 5.5 point of intersection, that is our key element, and we have the key row as s2 and key column as x1. So with same thing we have written that second iteration, that is nothing but the second table we are going to draw, since we have not arrived to the optimal solution. And now we are going to write it again. Always remember that key row is nothing but the leaving one, key column is the entering one. Entering one means in the place of s2 we have to enter x1. Okay, that means in this table we have what we have to replace s2 as x1. So here in place of s2 in new table we will not write s2, we will write here x1. Okay, so we have drawn here, you can see. See here we have in the previous we had x2 as the first variable. Okay, basis, same we have written x2. Okay, but the second one for s2 is a leaving variable. We have already mentioned it is s2 is a leaving variable. In the place of leaving we are getting x1. So in new table comes the x1, and s3 will be constant because there is no change in it. Again the same procedure like we have followed on the basis of the formula like previous table. The same thing we are going to follow. We are going to determine first the value of x1 because this is the entering variable. This is the golden rule that whenever we are making the table, first we have to determine the entering variable, because this is the variable, the answer whatever comes is being used for other than entering variable, that is to find the x2 here. Other than entering variable means x2 and s3 for this particular, because x2 is the entering variable for this particular table. So now we are going to find out first this one, this value, that will again put it into the same formula which we did for the previous table. Same thing we'll do, and other than the entering variable, same thing here. Multiply, we very well know that multiplier is nothing but the corresponding value, and it will take the negative sign. So here we can see that for here, since we are making for x2, so for x2 the corresponding value is 0.5, so we'll change its sign, that is minus 0.5, and for s3 it's 1, so it becomes minus 1. Okay, and we find all the answer and after putting the answer whatever we get into the table, we get here zj as 30. How do we get that? So here, see, I told in case if it is cb is 0, you don't need to multiply, but if there is anything greater than 0, you have to multiply and add it. So how do we arrive at zj? That is nothing but 40 into 0, that is 0, again plus 30 into 1, so we get 30. Again for this x2 value, how we will get that? 40 into 1, 40 plus 30 into 0, 0, so the total is 40. Okay, and for s1, 40 into 0.015 plus 30 into minus 0.07. Okay, what you have to add this to, we'll get the answer here. Okay, like this, do for everything, and then we have to find the optimal solution, if it is the optimal solution or not. For that we are doing is zj minus cj. Okay, zj value is 30, cj is 30, so 30 minus 30, 0, 40 minus 40, 0, and so on. Like for all these things, since it is 0, the same value zj value will be represented, that is written here. Okay, now we see in this table, since it is 0, okay, so what we say, in order to be an optimal solution, zj minus cj has to be equal to or greater than 0. Okay, so in this table, in the second iteration, we have got as 0, it is a positive value, so and other things also remains positive. Okay, so this is our optimal solution. So we have to find what how much unit of x1 and x2 has to be produced, and what will be our maximum profit. So how do we do that? So just go for basis. Okay, here x1, what is the value? Solution. Okay, 18.18, x2